NEET Academy, and in today's class again we are going to discussing the live NEET Chemistry Mock Test number 9 question paper, right? Okay, let's begin the session. Yes, dear student, question number 46, that is which of the following would have a permanent dipole moment? They are given option number 1 BF3, option number 2 SiF4, option number 3 SF4, and option number 4 XeF4. Yes, dear children, see here, I will explain with the help of one and one. First one, BF3, I will take BF3. This is having a structure that is trigonal planar. BF3 is having a structure trigonal planar, and due to this trigonal planar, the vector dipole moment, the vector sum of these all three becomes 0, hence the dipole moment of this BF3 is equal to 0. And number 2, that is SiF4. SiF4 is having a structure of tetrahedral. SiF4 is having a structure tetrahedral, and one of the fluorine atom which cancels its bond, which cancels its dipole moment to 0, and along with all the three, hence this SiF4, the dipole moment of SiF4 is also 0, and that is, I will directly go to the option number, I will go to the option number 4, that is XeF4. XeF4, due to the presence of lone pair of electrons on the head of this xenon, again the structure of this one is square planar. XeF4 is having square planar, and due to the plane of symmetry, the dipole moment of XeF4 is also 0. And but here the option number 3, that is SF4, option number 3 SF4 is having a bond dipole moment, that is 0.632. How it has been got? That is they have got it by experimentally. Yes, they have got it by experimentally by Stark effect. Hence option number 3 is the only molecule which is having a permanent dipole moment in the among those four. 47, the radiation corresponding to the transition n is equal to 4 to n is equal to 2 in the hydrogen atom falls on a certain metal. The work function is 2.5 electron volt. The minimum kinetic energy of the photoelectron will be, they have asked to calculate the minimum kinetic energy of the photoelectrons. Hence, look at this one, the Rn is equal to, this is Rn is equal to 13.4, Rn not, this is En is equal to 13.6 divided by n square. Look at here, En means E2 is equal to 13.6 divided by 2 square, that is equal to 13.6 divided by 4. The answer will be 3.4 and E4 means En means E4 that is equal to 13.6 divided by 4 square. This will be 13.6 divided by 16. The answer for this one is 0.85. Okay, next delta E is equal to that is E2 minus E4 that is equal to 3.4 minus 0.85, right? 3.4 and 0.85, if we deduct it, yes, that will be 2.55 electron volt will be the yes, 2.5 electron volt. Now kinetic energy is equal to they have given, that is delta E minus work function h nu naught, right? Therefore delta E is nothing but h nu. I will substitute here, that is 2.55 minus that is 2.5 work function they have mentioned here. The work function is mentioned here. Therefore the answer will be 0.05 electron volt. Let us read the options. Option number, they are given 0.05 electron volt, this is wrong, and 2.55 electron volt, this is also wrong, and 4.45 electron volt, this is also wrong, and the right answer is 0.05 electron volt is the answer. Yes. Okay, let us move to the next question. The direction of the given reaction in the forward direction. The direction of the given reaction in the forward reaction. They have given N2 gas molecule, 3H2 in a gaseous molecule is a gaseous molecule, forms at equilibrium 2NH3 gaseous molecule. Option number 1 they have given Q is less than Kc. Q is nothing but reaction quotient is less than Kc, and second option reaction quotient is equal to 0, and third one reaction quotient is equal to Kc, and fourth one the reaction quotient Qc is greater than Kc. But here according to this reaction, when the reaction attains the forward reaction and the value of Kc is greater than the reaction quotient, hence Qc is less than Kc is the answer. The right option is first one. Next, given below are the two statements. Statement 1, in a CrO5 the oxidation number of Cr is plus 10. Is it possible? Let us see. In CrO5 there are 4 peroxides, and each peroxide is having charge. Each peroxide is having charge -1, and one oxide and which is having a charge -2. And let's calculate the oxidation state of the CrO5. So Cr I have taken X plus of 5 oxygen out of 4 oxygen. So 4 into -1 because 4 oxygen are peroxide state, and plus 1 oxygen is in oxide state is equal to 0. This will becomes X minus 4 minus 2 is equal to 0, and X is equal to 6 is the answer. Then the oxidation state of CrO5, the oxidation state of Cr in CrO5 is plus 10 they have given, hence statement 1 is wrong because the oxidation state of chromium in CrO5 is 6 plus 6. Next, H3PO2 is a tribasic acid, statement 2E has given. H3PO2, look at here, H3PO2, H3PO2 on dissociation it will give H2PO2 minus plus H plus. It releases only one hydrogen atom. It releases only one hydrogen atom. Hence, it is not a tribasic acid. It is a monobasic acid. What is the basicity of an acid? What is basicity of an acid? It is the number of H plus ions produced during the dissociation of a particular acid. So here it is based on that one. If it releases 1, it is a monobasic. If it releases 2 hydrogen atoms, then it is dibasic. If it releases 3 hydrogen atoms, it is tribasic based on the availability of number of hydrogen atoms during the dissociation. Right? So hence statement 2 is also wrong. Hence statement 1, that is here both statement 1 and 2 are incorrect. The right option is 4. Let's move to the question number 50. Percentage of selenium in peroxidase anhydride enzyme is. The percentage of selenium in peroxidase anhydride enzyme is 25%. Means the percentage of selenium present in the peroxidase anhydride enzyme is 25%. The availability of selenium by weight. 25% is in the compound. The weight of the compound is 25% in the peroxidase enzyme, and atomic weight of this one is 78.4 unified mass. Then minimum molecular weight of peroxidase anhydride enzyme is. They have given option number 1. They have given option number 1 3.136 into 10 to the power 3 grams per mole, 31.36 grams per mole, 3136 grams per mole, and then 3136 into 10 to the power 4 grams per mole they have given, 3.136. Let's discuss regarding this one. See here, it is mass of anhydrase, that is peroxidase anhydrase. Peroxidase anhydrase is, I have taken as X, and here is a formula, that is equal to mass of selenium, atomic weight of selenium into percentage of selenium divided by 100, percentage of selenium into mass of peroxidase anhydrase, that is X. Therefore, X is equal to that is atomic weight of Se. This is atomic weight of Se, right? Atomic weight of Se into 100 divided by 0.25 is the, and after simplification 78, the atomic weight is, they have given 78.4 into 100 divided by 0.25. It will be 7840 into 4. This will becomes 31360 grams per mole, and 3.136 into 10 to the power 4 grams per mole is the answer. Therefore, the right option is option number 4. Yes, dear students, let's move to the next question, that is 51. Statement, again they have given the statement 1. the radius of second orbit of helium is equal to that of the first orbit of hydrogen atom. Clearly he has mentioned here, the radius of second orbit of helium is equal to that of first orbit of hydrogen, but it is wrong. Always the radius of second orbit of helium is double. Helium is double to that of the first orbit of hydrogen, because helium is having atomic number 2, right? But helium atom in its first unielectronic system, it is having the radius double than that of the hydrogen. Therefore option means statement 1 is wrong. Statement 1 is wrong. And next, the radius of an orbit is directly proportional to n square and inversely proportional to the z. Means this is the equation, that is Rn is directly proportional to n square divided by z, that is Rn is equal to after removing the proportionality constant, we will get a naught here and n square into z. Clear? So it is directly proportional to Rn directly proportional to n square, and the same Rn is inversely proportional to 1 by z. Therefore statement 2 is right answer. Therefore the right option among the four choices is statement 1 is incorrect and statement 2 is correct, that is option number 2. Let's move to the question number 52. Consider the following statements. 2-chloroethanoic acid is more acidic than ethanoic acid. For option, they have given the compound 1, that is 2-chloroacetic acid. Ethanoic acid is nothing but acetic acid is more acidic than the ethanoic acid. Next, acidic strength order in the given below, that is formic acid is greater than acetic acid and acetic acid is greater than the alkyl 2-methyl substituted acetic acid. So among these, as the number of, in previous question paper we have discussed regarding this one, you please move to there and check the same answer for the same question. Here, as the number of donor group increases, the basicity decreases. Hence here the CS3 group is here 2 CS3 group along with 1 R group. Therefore the formic acid is more acidic than the acetic acid, and acetic acid is more acidic than the 2-methyl substituted alkyl acetic acid. Hence the second one is also right. And here chloroacetic acid, the 2-chloroethanoic acid is more acidic than the ethanoic acid. See here, chlorine is the electron withdrawing group, right? Chlorine is the electron withdrawing group. Hence it increases the acidity of the particular acid when it is substituted to the chloroacetic acid, means acetic acid. Hence chloroethanoic acid is more acidic than the ethanoic acid. Hence first statement is also right. And here the acidic strength of order again here given in the third option also. Look at here, the nitrile group, alkane nitrile is less acidic than the aldehyde, is less acidic than the hydrocarbon. But basically the nitrile group is more acidic than the aldehyde, which is more acidic than the hydrocarbon, and hence the third one is wrong. Therefore the only two statements follows in the given statements. Therefore option 1 and 2 only the right answer. Therefore the right option is option number 2. Next, move to the question number 53. Which of the following pairs of compounds are isostructural? Among the given, look at here, XeF2, I will go with the explanation. XeF2, the structure of XeF2 is like this. This is linear, and next along with IF2, IF2 minus, this is a structure of IF2 minus, and both are having linear structure. And whenever come across this one, option number 2, NS3, in yesterday question paper, in question number 8, I have discussed with the geometry of this NS3 along with BF3. So these two, NS3 and BF3 together, they will show. This one is a square pyramidal. Sorry, this one is trigonal pyramidal. NS3 is trigonal pyramidal, and this one is BF3 is trigonal planar, right? Therefore those two are not isostructural. And here PCl5 is that is trigonal bipyramidal. PCl5 is trigonal bipyramidal, and this one is square planar. ICl5 is square planar in structure. And here CO3 2 minus is this is a structure of CO3 2 minus. S CO3 2 minus. Next, this one is third one, and SO3. This is the structure of SO3 2 minus. Hence, this is also not isostructural. Therefore the right option is that is option number 1. Therefore the right option is option number 1. Hence the XCF2 and IF2 follows the compounds of isostructural structure. Next, move to the question number 54. Given below are the two statements, right? Given below are the two statements. One is labeled as assertion and A, and other is labeled as reason R. So let's move to the assertion. The addition of HBr to 1 butene gives 2 optical isomers. 100%. Let us discuss with this one. 1 butene CH3 CH2 CH double bond CH2 is the structure of 1 butene. If you add this one according to Markovnikov rule, an unsymmetrical molecule is added to an unsymmetrical alkene, it will forms the positive part of the molecule will attaches to the carbon containing more number of hydrogen, and the negative part will be attaches to the carbon containing least number of hydrogen. Therefore CH3 CH2, right? And here CH and Br, and here CH3, and I will write it as in the form of isomer CH3 this is H, and this is C2H5, and this is Br. When kept in front of the mirror, this will shows definitely what will happen, sir. CH3 C Br, and this is H, and this is C2H5, right? Clear? So this is dextro compound, and this is levo compound. What he has told, the addition of HBr to 1 butene gives 2 optical isomers. Hence the first option is the assertion is right. The assertion is right. And next, The product contains one asymmetric carbon. If there is a asymmetric carbon, then it is called as a chiral. Right? That's what the reason is also right. Therefore, that is both assertion and reason are true, and reason is the correct explanation of assertion. Therefore, the right option is option number 3. Which of the following nitrogen containing compounds gives Lessines test? There is a condition. If there is a presence of nitrogen containing compound, and it must contain carbon also. Why? Because when it reacts with Lessines compound, means sodium fission extract, so that must, so sodium fission extract is there. If there is a sodium fission extract is there, it will form definitely sodium cyanide as a byproduct. Hence, look at here, the compound A. Compound A is phenyl hydrazine. This is containing phenyl hydrazine containing carbon as well as nitrogen. And glycine. Glycine is the compound of amino acid, and this is also containing carbon and nitrogen. And urea, in the structure of urea also there is a carbon and nitrogen is present, and the only one, that is hydrogen. Hydrogen is not containing what? Hydrogen is not containing carbon at all. Therefore, the only compound which is not containing carbon is hydrogen. Therefore, the hydrogen does not give Lessines test. Therefore, the right option is option number 4. A, B, C and A, B and C gives the Lessines test because they nitrogen containing compounds having carbon along with it. Next, which of the following reactions will give an alkyne as the major product? Alkyne as the major product. Let us see here in front of it one, in front of the molecule, all they have given in compound 1. I will go compound 1, CH3, C, Br, next CH, Br. If you react it with zinc dust, right, there is an elimination of 2ZnBr2. There is an elimination of 2ZnBr2, and as a result CH3, C triple bond CH will be formed. The first option is right. And next, again here they have given in a second reaction CH3, CH2, CH, Br and Br, right? Let's move to, in the presence of first, they have reacted with alcoholic KOH, by reacting with alcoholic KOH, what will happen, sir? Dehydrohalogenation reaction takes place. Hence, the elimination of nucleophile takes place. Due to that reason, elimination of KBr minus H2O takes place, and hence CH3, CH double bond CHBr. And after that, reacting with NaNH2, sodamide, right? This sodamide, after reacting it with sodamide, again it will give, look at here, that is CH3, CH3C. Again there is a elimination of NH3. I will write those product here, NH3 plus NaBr will be eliminated out, and next CH3, C triple bond CH will be the final product. Therefore, the second reaction is also gives alkyne, and third reaction, two equivalents of sodamide reaction, again it will also gives CH3, C triple bond CH3. Therefore, all the three reactions gives alkynes by the reactions. Therefore, the right option is all of the above, that is fourth. Next, when 5 moles of a gas is heated at a constant value, temperature is raised from 410 to 420 Kelvin. Heat supplied to the gas is 600 joules. Then the correct statement is, we all know that the thermodynamic equation, that is delta H is equal to delta U plus R delta T, right? But we know that PV is equal to RT, therefore delta H is equal to delta U plus P delta V. But during the this one is heat is, right? Therefore P delta V, and during the isothermal process, temperature is constant, and during the isochoric process, what happens? Delta V is equal to 0, hence delta H is equal to delta U, right? Now let's move to this one, delta U. Next, this can be taken as a delta E also. Again, there is a equation we have delta E. Next, delta E is equal to Q plus W. Delta E is equal to Q plus W. But W is equal to what? W is equal to minus P into delta V. Again delta V is equal to 0. Then W is equal to also 0. Then if delta W is equal to 0, delta E is equal to, substitute this one here, Q, because work done is 0. And then the right answer is delta E is equal to, work done is 0 they have given. And next, delta E is equal to delta Q, and then if both are equal, then the heat supplied, that Q is equal to, that is 600 joule. Therefore the option 2 is the right answer. Next, move to the next question. Which of the following transition metal have lowest first ionization enthalpy? Simple. Here they have given the 4 D block elements. Option 1 chromium, option 2 copper, option 3 cobalt, option 4 iron, right? Look at here, copper is having 3D10 4s1, and cobalt is having 3D7 4s2, and iron is having 3D6 4s2, and chromium is having 3D5 4s1. So in this configuration, the chromium is the only element having the lowest ionization enthalpy, because when we follow the ionization enthalpy order according to the NCERT textbook, the first electron removing from the orbit of chromium is very easy, even if it is half orbital. But in the case of the second ionization enthalpy of chromium is maximum, because the d orbital is completely half filled, but s orbital is not affected by removing an electron. Hence the first ionization enthalpy of chromium is least. And next, move to the question number 59. Which of the following compound is most stable among all? See, the compound which is aromatic, then which is having more stability. Look at here, this one is anti-aromatic system. This one is anti-aromatic system. This one is non-aromatic. Non-aromatic. Even after having alternate single and double bond, it is non-aromatic. And this is also having alternate single and double bond, but it does not follow the 4n plus 2 pi electron rule. That's why it is also anti-aromatic. And this is the only product which follows the 4n plus 2 pi electron rule. 4n pi electron rule. Hence option 3 is the right. Therefore it is most stable among the all compounds. Clear? Okay. Next, move to the question number 60. In which of the following equilibrium Kc and Kp are equal? Let's discuss. Here is the equation. Kc is equal to Kp into RT raised to delta Ng. Okay, this is the equation. Let's calculate the delta Ng of the all 4 options. First one, second one, third one, fourth one. See, delta Ng, delta Ng, and delta Ng. Look at this. First one, in the product sides, there are 2 carbon molecules, therefore 2 carbon gaseous molecules, therefore delta Ng is nothing but the sum of all the gaseous atoms which are present in the reactant side, product side and reactant side. Therefore 2 minus 1, that is equal to plus 2 minus 2 gets cancels. There is 1 gaseous molecule, minus 1, delta Ng value becomes minus 1. And this is, if you go to the second option, Hi, this is plus half minus 1. This will be 0 for second one. Next, fourth one, that is, this will be not considered, and 1 gaseous molecule is here, minus 2 is here, and minus 1 is here, right? So minus 2, minus 1, plus 1 minus 1 get cancels. Here 2 molecules, and here in fourth option there are 2 molecules of HF and 1 molecule of XeOF4 minus 1 minus 1. Therefore this will be minus 2 plus 2 get cancelled. This will be 1. Right? Okay. Now substitute these values here. After substituting the values here, the value should be what? Kc and Kp should be equal. And Kp is equal to Kc when if we substitute the option 2 value. If delta Ng is equal to 0, then RT value becomes 1, then this will become completely equal each other. Therefore, the right option is option number 2. Next, move to the question number 61. Here, the correct order of the basic strength of methyl substituted amines in aqueous solution is, by considering 2 points. First one, here they have given, that is secondary amine. Secondary amine is greater than primary amine, greater than tertiary amine. Here tertiary amine, in second option they have given tertiary amine is greater than primary amine, greater than secondary amine. And in third option he has given tertiary amine greater than secondary amine, greater than primary amine. And here primary amine greater than secondary amine, greater than tertiary amine. But actually, based on the 2 factors, that is first one is steric hindrance, and second one is solvation effect. Solvation effect. Here among these four options, the first option will follows the correct sequence, that is secondary amine is greater than primary amine is greater than tertiary amine is the right answer for the 61 question. Therefore, the right option is option number 1. Let's move to the question number 62. Again, they have given the decreasing order of the boiling point of the following compounds. Here, option number 1, they have given 3-methyl-butane 2-ol, 2-methyl-butane 2-ol. Next, pentane 2-ol they have given. And here, pentane in option number 2, pentane 1-ol, 3-methyl-butane 2-ol, 2-methyl-butane 2-ol. Next, 2-methyl-butane 2-ol and 3-methyl-butane 2-ol and pentane 1-ol. Option number 4, 2-methyl-butane 2-ol, pentane 1-ol and 3-methyl-butane 2-ol. See here, as the number of carbon atoms present in a chain, the boiling point goes on increasing. Here, and the right option is option number 2. See here, pentane 1-ol, greater than 3-methyl-butane 2-ol. See here, why this option is correct, I am going to explaining here. The pentane 1-ol, so 1, 2, 3, 4, 5, right? Pentane 1-ol, this one is 5 carbon atoms and the numbering from here. And the numbering should be from 2, 3, 4, 5, OH. So 1, 2, 3, 4, 5, right? Okay. Next, here the 3-methyl-butane 2-ol, 3-methyl, if methyl is substituted at the position of 3, 1, 2, 3, 4, OH and here CH3. And this is CH3 OH. This is a 3-methyl-butane 2-ol. Butane 2-ol means that should be attached to, yes, 1, 2, 3, 4. Next, this one is 2-methyl butane 2-ol, butane 2-ol, OH. So 1, 2, 3, 4. See, as the branching increases, the boiling point decreases. But among these, this one is in the long chain, hence its boiling point more. And here number 3, look at here, the single carbon is containing both OH and CH3 group. Hence, there is a requirement of surface area is less. Hence, this is least boiling point as compared to this second one. Therefore, the right option is the pentane 1-ol greater than 3-methyl-butane 2-ol greater than 2-methyl-butane 2-ol. Therefore, the right option is option number 2. And 63. Look at here. Select the correct order of the boiling point. First option, PS3 less than ASH3 less than SBH3 and NS3 less than PS3 less than ASH3 less than SBH3, and here PH3 less than ASH3 less than SBH3 less than NS3 and PS3 less than NS3 less than ASH3 less than SBH3. But the correct boiling point order is option number 3. Why? The reason is NH3 forms H bonding, means hydrogen bonding. Hence, its boiling point is more as compared to these 3. And based on the increase in their atomic number, boiling point goes on increasing Therefore, PS3 is less than AS, AS is less than ASH3, ASH3 is less than SBH3, and then finally the NH3, the only NH3 molecule forms the hydrogen bonding. Therefore, this is the point of view we are going to considering the option number 3 as right answer. Let's move to the question number 63. The overall order of the reaction between the X and Y is 3. Which of the following rate equation must be? Which of the following rate equation must be correct? If on doubling the concentration of X, the rate of the reaction gets doubled. The right option is, there is no much discussion regarding this one, because already they have given the order is 3. Here option 2 and 4 are given, but comparing to option 2 and 4, they have told that the doubling the concentration of X, they have told. So if you double the concentration of X, then there will be a doubling of the point. Therefore, 64 is the right answer. 64, the right option is option number 2. And here, which of the following compound do not give Friedel-Crafts alkylation reaction or acylation reaction? There are two types of reactions, alkylation and acylation. OCH3, here only I will explain with the help of this compounds. OCH3 is the molecule, is the electron donating group, hence it is orthopara director. It is orthopara director, hence 2 ortho position and 1 para position is electron. These two are electron rich centers, and it is favorable for the Friedel-Crafts alkylation reaction or acetylation reaction. And option number 3, CS3 is also favor for, it is also the ortho and para director, and it is also electron donating group, and it is favors the 2 ortho and 1 para position for the electrophilic substitution reaction, hence it is favors the Friedel-Crafts reaction. And benzene is, there is no much explanation regarding this one, because primarily benzene undergoes Friedel-Crafts alkylation as well as acetylation, hence it is also having 2 ortho and 1 para position for the electrophilic substitution reaction. But here what will happen, if I take the example of NH2, NH2 is containing a lone pair of electron on its head, but it is favorable for the electrophilic substitution. But alkylation, especially Friedel-Crafts alkylation, when it come across, what will happen? We generate the electrophile here, and along with a charge carrier will also generated, right? This charge carrier is directly attracted by these lone pair of electrons, hence it will forms the compound like this. It will form the compound like this, NH2 plus and AlCl4 minus. Right? Due to this reason, the ring is deactivated completely. Hence, the right option is option number 2. And move to the next question. Which of the following is a fat soluble vitamin? Simple. There are vitamins A, D, E, K are what? Fat soluble, and B and C are water soluble. Therefore, the right option is option number 4. Let's move to the question number 67. The number of significant figures in 0.00256 and 1.004 are respectively. Simple. In a first number, the zeros preceded by the non-zero digits are not significant. Hence, the only 3 numbers are significant, and zeros between non-zero digits are significant. Hence, there are 4 significant figures. Therefore, here they are given option number 1, 3, 2, option number 2, 5, 4, option number 3, 3, 4, and option number 4, 6, 4. Therefore, option number 3 follows, that is 3, 4. Hence, the right option is 3. Next, the correct IUPAC name of the following compound is. Actually, what will happen here? There is no addition of this oxygen here. Then only the IUPAC name is correct, because the given one is matches to this one. So I will write this one as N triple bond C, then C double bond CH2, and here CH, right? Next, C, this one will match, combine together here to form CHO, and then this will forms C double bond CH2. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 5, right? 5. Next, now I will start to number this one. So 1, then 2, then 3, then 4, then 5. Now, see here, this one is 2 ethynyl, that is 2 ethynyl, right? This is 2 ethynyl. Next, this one is CHO is here. CHO at third position, therefore 3 formyl, that is 3 formyl, right? 3 formyl. Spelling mistake. Formyl, right? 3 formyl. And next, how many carbons are there? 5 carbons, therefore pent. Then pent. At fourth position again, alkene is there, pent 4-ene. Therefore, the right option is option number 2. Let's move to the question number 69. The inward sugar is an equimolar mixture of. There is none other than D-glucose and D-fructose are the answers. Therefore, the right option is 69. Question option number 1. S. The correct decreasing order of acidity of the following compound is. The correct order of decreasing order of acidity for the following compounds is. See here, it is having 2, 6 dihydroxybenzoic acid. It is more acidic due to the hydrogen bonding favored by the 2 ortho position oxygens present in the compound. Intramolecular hydrogen bonding takes place at a 2 ortho position. 2, 6 dihydroxybenzoic acid in benzoic acid. Because of this intramolecular hydrogen bonding, this one is having a more acidic nature. And later, the third option is also having intramolecular hydrogen bonding because of the 2-hydroxybenzoic acid is also forms the hydrogen bonding with the intramolecular hydrogen bonding with the carbonyl hydrogen, and that is OH oxygen. Therefore, this will comes in the second position, and this one is comparing to this one is least away from the what? Benzoic acid group. This hydroxyl group is least away from the benzoic acid group, and this is a third position. Therefore, the acidity strength of the third compound will be 3-hydroxybenzoic acid. And the fourth one is this one. This is para position, means 4-hydroxybenzoic acid. There is a maximum distance between the hydrogen and oxygen. Therefore, it is highly impossible to form the intramolecular hydrogen bonding as well as intermolecular hydrogen bonding. Therefore, this will comes in fourth position. Therefore, the first one is the order is first one is greater than third one. First one is greater than third one, and third one is greater than second one. Second one is greater than fourth one. Therefore, this is the order. Look at here. First 3, second 4. The first option is the right answer for the 70th one. Let's move to the question number 71. At 80 degrees Celsius, the vapor pressure of the pure liquid A is 400 mm of Hg, and that of the pure liquid B is 800 mm Hg, and if a solution of A and B boils at 80 degrees Celsius and 1 atm pressure, then amount of A in the mixture is, we have to find out the mole fraction, right? We have to find out the mole fraction. 1 atm pressure is equal to 760 mm of Hg. So look at here, Pt is equal to P naught A into XA, right? We have to find out the XA, plus P naught B into XB. Let's move to this one. Simple. P naught Pt is equal to P naught A into XA plus P naught B is there. P naught we keep it as it is. P naught B bracket of 1 minus XA, because XA plus XB is equal to 1. Clear? Okay. Now what we have to do? Simple. Again, substituting the values inside the equation and simplify it. So Pt they have given total pressure, that is 1 atm pressure. 1 atm pressure is nothing but 760 mm is equal to, here they have given Pa, how much? That is the pressure of A is 400 into XA plus Pb 800 bracket of 1 minus XA, right? So simplifying these, 760 is equal to 400 XA plus 800 minus 800 XA, right? Now bringing the similar terms one side, we will get 760 minus 800 is equal to 760 minus 800 is equal to, we will get, that is 400 into XA minus 800 into XA. After subtracting this one, the value will come here. I will write this one, simplify this one, and finally finalize this one. So this will becomes minus 40 is equal to minus 400 XA, and XA is equal to 40 by 400, minus minus it cancels, 40 by 400, and this will becomes 0.1, and therefore percentage of XA is equal to 0.1 percentage multiplied by 100 will be 10%, multiplied by 10%. Therefore, the right option is 10% mole. Let's move to the question number 72. If cell constant of a cell is 0.1 per centimeter and resistance is how much? 0.2, then conductance will be, that is G is equal to 1 by R, that is equal to G 1 divided by R value is 0.2, right? See here they have given one cell constant is 0.1 per centimeter, and this one is 0.2 ohm. They have not mentioned it's SI unit, ohm, and then the conductance will be Yes, and they have given four options. Option number 1 0.02 per ohm, option number 2 5 per ohm, and option 3 that is 0.05 per ohm, and option 4 0.01 per ohm. This one is, so first one I will multiply it with 10, because simplification it will be very easy. Multiply it with 10 by 10. This will become 10 divided by 2. 2 ones are 2 5s are. Therefore, the right option is 5 per ohm. Therefore, the right option is option number 2. Next, move to the question number 73. The correct IUPAC name of the given compound is. There he has given. See here, first diamine, right? Next, diamine after chlorido, then nitrito, next munde further nitrito N, because it is bonding with N, it is a ambidextrous ligand which bonds with N. Therefore, this is nitrito N. Later, platinum 2. How the platinum is 2 oxidation state? This one is the charge on NH3 is 0 and the charge on Cl is -1, charge on NO2 is -1. Therefore, X plus 0 -1 is equal to 0. Therefore, X minus 2 is equal to 0. X is equal to 2. Therefore, the charge on platinum is 2. Therefore, diaminochlorido nitrito N platinum 2. That is option number 1 is the right answer. Next, move to the question number 74. Cannizzaro reaction is not given by. Simple. See, first one, second one, third option. The first option is trimethyl acetaldehyde. No alpha hydrogen atom. No alpha hydrogen atom. And in benzaldehyde also no alpha hydrogen atom. Next, in formaldehyde also no alpha hydrogen atom. The only one is acetaldehyde contains CH3 C double bond O. This hydrogen is alpha hydrogen. Therefore, which does not give. Therefore, which does not give what? Which does not give. That is Cannizzaro reaction. Hence, option number 4 is the right answer. Next, move to the question number 75. Oxalate ion is simple. I will write the structure of oxalate. C double bond O. C double bond O, O minus. C double bond O, O minus. Right? There are what is 2 minus charges. Due to that reason, we write it as C double O 2 minus. C double O. One second. C2O4. C2O4 2 minus. Therefore, it is an anionic. Because of containing 2 donor atoms, it is a bidentate. Because of the presence of minus charge, it is anionic. Bidentate ligand, hence it is anionic bidentate ligand, hence option 1 is right answer. Next, match the list 1 with list 2. Simple. Look at here. PCl5. Previously I told that is the structure is yes, PCl5 is having a trigonal bipyramidal, and that is SF6 matches with octahedral, and NH3 is tetrahedral, and BCl3 is trigonal planar. So A matches with 3 and B matches with 4. A3B4, then C1D2. Therefore, the right option is option number 1 for 76. And next, the half-life for the first order reaction is 69.3 seconds. The required time for 80 gram of reactant to reduce 20 gram will be log 2 value they have taken 0.3, but we will take as it is for the complete log value and solve it. Look at here. First I will go with the half-life period, that is because I want to calculate what? I want to calculate the rate constant first. Therefore, K is equal to 0.693 divided by T half. T half he has given 0.693 divided by 69.3. This will becomes 0.01 per second. This will becomes 0.01 per second, right? And now substitute K is equal to 2.303 divided by T into log of R naught divided by R, right? So, okay, R naught divided by R. Now, let's move to the question. Now, T is equal to, we have to find out the time, that is 2.303 divided by K into log of R naught divided by R. So, now substituting the values, 2.303 divided by 0.0, I will write it as 10 to the power minus 2 into log of 80 divided by 20. So, 21 za, 24 za. This will becomes 2.303 into 10 to the power 2 into log of 4, and this will becomes 230.3 into log of 2 square. So, 2 square will becomes log A raised to B. So, B log A, the value of log A raised to B is B log A, hence 2.303 not 230.3 into 2 into log 2. This will becomes 460.6 into 0.3010. This will becomes 138.65 seconds. T will be, so the right option will be option number 1. The right option will be option number 1. Yes, let us move to the next question. Yes, given below are two statements. That is, one is labeled as assertion A and other is labeled as reason R. Now, assertion, I will read the assertion. Zinc, cadmium and mercury do not show the properties of transition elements. There is a statement for assertion. See here, zinc, mercury, zinc, cadmium and mercury. Zinc, cadmium and mercury. Mercury is Hg, right? The oxidation state is 3D10 4s2. This is 4D10 5s2. This is 5D10 6s2, right? So, these three are even in their common oxidation state as well as the atomic state. They do not show the transition properties, right? They do not show transition properties and they show complete D10 configuration, right? They do not show transition properties, nothing but D10 configuration. If there is a DD transition, then they are called as D block elements. Hence, these are considered to be as pseudo transitional elements. Pseudo transitional elements. Therefore, the first option is, assertion is right. See here, What is that? Zinc, cadmium and mercury, even in their common oxidation state as well as in their atomic state, they show D10 configuration, hence they are considered to be as pseudo transitional elements, hence assertion is right. And next, zinc, cadmium, reason is zinc, cadmium and mercury have completely filled valence shell electronic configuration. See here, they have completely filled valence shell configuration, therefore reason is also right. Therefore both assertion and reason are true, and reason is the correct explanation of assertion, hence the right option is option number 3. And next, move to the question number 79. They have given here 3a is equal gives rise to 2b, right? The rate equation for this one, the differential rate equation we have right here, that is change in the concentration of reactant, that is A with respect to time, is equal to change in the concentration of B with respect to change in the concentration of B with respect to time. Now after this one, please look at this one. Now I will write this one as change in the concentration of B with respect to time is equal to minus 2 by 3. I will bring this 2 to here, and 2 by 3 change in the concentration of A with respect to time. So this is the right option. In which option they have given? That is option number 2, minus 2 by 3 dA by dt. That is the right answer for this one. Hence this is option 2 is the right answer for question number 79. Now move to the question number 80. Statement 1. The law of conservation of mass is valid for nuclear reaction. This is a completely wrong statement. Why? Because the law of conservation of mass is valid for all types of reaction. Therefore, statement 1 is wrong. As per the law of conservation of mass, in a chemical reaction, the total mass of the reactant and product remains same. Whatever the compound they may react in the reactant side, the same will be comes in the product side, and their masses, just there is a reorganization of molecule takes place, but there is no change in the molecules. Hence the statement that is 2 is right answer. Therefore statement 1 is incorrect and statement 1 is incorrect and statement 2 is correct. Therefore option 2 is the right answer. And move to the next question, that is oxidation state of central atom in carbon dioxide. This is a very easiest question they have asked, that is X plus how many oxygen are there? There are 2 oxygens and each carrying -2 charge. Therefore x minus 2 is equal to 0, x minus 4 is equal to 0, x is equal to plus 4. Therefore the right option is option number 1. And move to the next question, question number 82. Match the following species given in column 1 with the chemical formula given in column number 2. Simple. The most abundant element, remember, the most abundant element is, that is aluminium. The most abundant element is what? That is aluminium. Next, the no d orbital element is boron. Next, lowest melting point element is gallium, and inert pair effect showing element is thallium. So that is A matches with 4, and next B matches with 3, and C matches with 2, and D matches with 1, and the right option is A4, B3, C2, D1. Therefore, the right option is option number 4, A4, B3, C2, D1. Okay, right. Move to the next question. That is 83. Identify the factor from the following that affects the electrolytic conductance of the solution. The nature of the electrolyte is conductance of a solution means here the electrolytic conductance which affects the conductance of the solution is, first one is the A statement is the nature of the electrolyte added, and B is nature of the electrode used, C is concentration of the electrolyte, D is nature of the solvent used. See here, actually the electrolytic conductance depends on, first one is the nature of the electrolyte added, and second one concentration of the electrolyte, and next the nature of the solvent used. The nature of the electrolyte is, there are two types of electrolytes, one is a strong electrolyte and one is weak electrolyte. During the conductance of during the electrolytic conductance, what will happen? We must have to know that one whether the given electrolyte is given electrolyte is a strong electrolyte or weak electrolyte, and study the nature of the electrolyte and then we will use it. For that reason, first one is nature of the electrolyte added is right answer. And next, the concentration of the electrolyte used. Basically, concentration of the electrolyte means molarity. Yes, the molarity will affects the conductance of the solution. Hence, more the conductance, more will be the less will be the what concentration of the electrolyte. Therefore, see here, and therefore the concentration of the electrolyte is also one of the factor where the electrolytic conductance depends. And next, the nature of the solvent used. The nature of the solvent used. In the electrolytic conductance or ionic conductance, we use the polar solvents. Hence, nature of the solvent is also very important. But the nature of electrode used is not come in contact, and it is not to be considered. Hence, the right options are A, C, and D. Option number 4. And see here, the correct order of stability of alkene is, first one is the trans 3, first one is 1-hexene, second one is a cis 3-hexene, third one is a trans 3-hexene. Look at here, trans 3-hexene is most stable as compared to the cis 3-hexene, because the molecules which are present in the double bond means any molecule which is stable, which is said to be stable in a geometrical isomer, the molecules must present opposite in directions. So double bond, if there is a presence of double bond, the two molecules, that is cis 3-hexene is right. So C2H5 C and then 3 4. This is cis 3-hexene. Yes, these two similar molecules are on the opposite side, shows more stability as compared to the same side. Hence, this one is more stable. The priority gives to the trans 3-hexene first priority, and later cis 3-hexene, the similar molecules are present on the same side of the double bonded carbon. Hence, the stability is decreases due to the presence of similar molecules of the same size, and there will be a what it is, eclipsed conformation will be occurs. Due to that reason, the trans hexene, there is a repulsion takes place. Due to that reason, this cis hex 3-ene is less stable as compared to this one, and least stable is 1-hexene. This comes in third position. Therefore, the stability order will be follows 3, 2, 1. The stability order will be 3, 2, 1. Therefore, that is option number 2 is the right answer for 84th question. Next, here The given below are two statements. One is labeled as assertion and other is labeled as reason R. So assertion is the first ionization energy of nitrogen is lower than oxygen. This is wrong. Why? Because the nitrogen in its outermost orbital, it is containing 3 electrons. Those 3 electrons are very difficult to remove. Hence, it is more stable in a half-filled configuration, and oxygen is containing 4 electrons in its outermost orbital. Therefore, oxygen, it is very easy to remove an electron from the 2px. Right? For that reason, it is very easy to remove the electron from the 2px because 1 electron is extra here. Due to this reason, the stability of the oxygen is as compared to nitrogen is very less. Hence, the first ionization energy, the half-filled nitrogen is greater because nitrogen possesses half-filled configuration. Hence, the first statement means assertion is wrong. Next, reason. Across the period, effective nuclear charge increases as we move from left to right. As we move from left to right, the atomic number goes on increases, and due to the increase in the atomic number, the effective nuclear charge is also goes on increasing by unity, because nuclear charge is directly related to what? Nucleus, and atomic number is also related to what? Nucleus, because inside the nucleus only the number of protons are present, right? So for that reason, as we move from left to right, the effective nuclear charge increases. Hence, reason is right. Therefore, the assertion is false and reason is true. Hence, the right option is option number 2. Move to the question number 86. In the 6th period, the modern periodic table, the electronic energy levels arranged in the order, that is none other than first option. We are directly, there is first we go to the 6. S is less energetic than, that is 4F. 4F is less energetic than 5D. 5D is less energetic than 6P. Therefore, P is more energetic. Hence, therefore, this is the right order of arrangement of the electronic energy level. Therefore, first option is the right one. And move to the 87 question. Which of the following molecule has the maximum bond angle? Maximum bond angle. See here, this one is having 180 degree, and option number 1 is having I3 minus is having 180 degree. Option number 2 is having 104 degree. Next, option number 3 is having that is 120 degree. Option number 4 is having 107 degree. Right? So 107 degree. Now comparing to all these 4, the maximum angle possessed by the molecule is I3 minus. Therefore, option 1 is the right answer. Now let's move to the question number 88. A basic buffer solution contains equal concentration of base and its salt. If value of Kb is 10 to the power minus 5, then pH of the buffer solution would be, he has told, right? So that is POH is equal to PKB into PKB plus log of concentration of salt divided by concentration of acid is the formula. Now first we have to calculate the POH. What he has taken, and he has given the option 1 for 8, and option 2 10, option 3 12, option 4 9. This is the very easiest way to calculate one. See here, POH is equal to PKB, POH is equal to PKB. After removing that one, this will become, if we apply log minus log Kb, then plus log concentration of salt by concentration of acid, right? Now POH is equal to minus log value, minus Kb value, minus log of, here he has given 10 to the power minus 5, he has given 10 to the power minus 5 plus log of 1, because the concentration of salt by acid is completely unity. Therefore, the value will POH would become, that is 5, and now pH plus POH is equal to, we have to calculate a pH value. So pH plus POH is equal to how much? 14. pH, the value of pH is equal to POH, 14 minus POH. This one is 14 minus POH. So 14 minus 5 will be 9. Therefore, pH of a solution would be 9 is the right answer. Clear? Now move to the question number 89. Question number 89, match the list 1 with list 2. See here, NaCl is the molecule, means here list 1 is electrolyte and list 2 is the Van 't Hoff factor. So NaCl is containing a number, NaCl Van 't Hoff factor would be 2, and C6H12O6 glucose is having Van 't Hoff factor 1, and K2SO4 is, K2SO4 is having 3 options, and Al2SO4 trice is having 5. So look at here, and how I have calculated this one, that is Van 't Hoff factor I is directly proportional to number of ions, right? Therefore sometimes Van 't Hoff factor is equal to number of ions, means if there is a 100% dissociation, alpha is equal to 100%. If alpha is equal to 100% means the degree of dissociation is 100%. Therefore, I value is equal to number of ions. Therefore, based on the availability of number of ions, I have marked here the Van 't Hoff factor. See here, the right option is A2, B3, C4 and D1. A2, B3, C4, D1. Therefore, the right option is option number 1. And the last question of this session is, which one is least reactive towards SN1? There is a order. Tertiary carbocation is more reactive than secondary, and secondary is more reactive than primary. Primary is more reactive than CH3 plus. Therefore, the reactivity towards the SN1 reaction is follows this order. Therefore, the least one is first one option. Yes. Therefore, the right option is option number 1 for 90 question. Yes, my dear students, this is the today's class, and now I request you to please help us to develop our community, and please share the videos to your friends to know about the various questions which have been asked in the competitive examination, and help us to grow more. And please like, share and subscribe to our channel. Thank you.